Namaskaram, and a very warm welcome to all of our Technical Teacher Certificate trainees joining us today. Have you ever wondered why some lessons stick with us for an absolute lifetime, while others are, let's be honest, completely forgotten by recess? Well, today we're going to focus on a truly transformative classroom transaction. We're looking at a pedagogical approach that literally has the power to completely change the way your future students engage with science, and honestly, with the whole world around them. In this explainer, we're diving straight into the experimental method. It's a fundamental technique, and it's going to be an absolutely essential tool in your teaching toolkit.
The core philosophy here is simple but incredibly powerful. Learning by doing, understanding by experience. What this really means is that true education simply has to move away from passive memorization. Look, we all know the traditional chalk and talk method, right? Where students just sit there and listen. But this approach, it flips that entire dynamic on its head. It's all about active, hands-on classroom engagement. You are putting the learning directly into the hands of the learner.
To help you really master this, our roadmap today is broken down into 4 key areas. First, the core of experimental learning. Second, the 6 crucial steps. Third, we'll look at teacher and student roles. And finally, number 4, the benefits and challenges.
All right, let's jump right into Module 1, Core of Experimental Learning, the Philosophy.
So, the experimental method is formally defined as a teaching method in which students learn through experiments, observation, and, this is the absolutely crucial part, the active discovery of facts. The whole focus shifts entirely away from you, the teacher, just lecturing about a fact. You're no longer just delivering information. Instead, you are setting the stage for their big aha moment.
Our source material actually provides this brilliant, comprehensive educational poster. It's available in both Telugu and English, which perfectly illustrates the universal nature of this pedagogy. It beautifully ties the whole thing together. The objectives, the steps, the examples, and the roles. It really maps out the entire ecosystem of a student-centered classroom designed to foster a genuine scientific temper.
And right at the heart of it is this: do, observe, learn. I really ask you as future educators to internalize this simple, powerful mantra. First comes action, then observation, and finally, comprehension. This sequence is the absolute heartbeat of developing a true scientific attitude in your learners.
Moving right along to Module 2, the 6 crucial steps, how it works.
So, here is the logical progression you're actually going to guide your students through. It all starts with the spark of curiosity. Step 1, identifying a problem or question. That naturally leads us to Step 2, formulating a hypothesis, which is basically making an educated guess about what's going to happen. Next comes the preparation in Step 3, planning the experiment. Then, the action itself in Step 4, experimentation. As that action unfolds, students execute Step 5, observation and recording. And finally, the big payoff, Step 6, conclusion. This is where they analyze the results to see if that initial hypothesis was actually correct. It's just a beautiful, rigorous process.
Let's make this a bit more concrete with some practical classroom examples from the source material. Instead of just writing 100 degrees Celsius on a chalkboard, imagine the impact when you let them actually heat the water, measure the temperature, and observe the boiling point and phase change themselves. The exact same goes for discovering the spectrum of sunlight using a prism, observing the effect of an acid on a base, or setting up a real experiment to prove photosynthesis in plants. These aren't just dry textbook facts anymore. They become real, tangible, unforgettable experiences.
Okay, let's shift gears to Module 3, Teacher and Student Roles, the Classroom Dynamics.
Now here is where the fundamental shift really happens. You are no longer the sage on the stage. You become the guide on the side. As the teacher, you act as a facilitator. You're selecting suitable experiments, providing the necessary materials, guiding the overall process, and of course, strictly ensuring safety. Meanwhile, the students, they are the active participants. They take full charge of the actual execution. They're following instructions, conducting the experiment sincerely, observing, recording, and analyzing. Basically, you prepare the environment and they do the discovery.
To successfully pull off this guide on the side role, you definitely need to prepare specific physical and digital tools in the background. Your essential teaching aids are going to include physical laboratory apparatus, things like beakers and microscopes, as well as models, biological specimens, informative charts and pictures, and even dynamic video or digital resources.
And finally, Module 4, Benefits and Challenges, Evaluating the Method.
Let's start with the merits, and wow, they are massive. Because this approach is entirely student-centered, it deeply develops practical skills and a true scientific attitude. It highly encourages self-learning and connects abstract textbook concepts directly to real life. And because they literally did it themselves, that knowledge is retained for a much, much longer time. Concepts are understood so deeply, curiosity spikes, and honestly, as they successfully navigate these experiments, you'll watch their self-confidence absolutely soar. It's a real game changer for innovative thinking.
However, as professional educators, we do have to be realistic about the logistics. It undoubtedly takes more time than just delivering a standard lecture. It carries specific material costs, and it can be pretty difficult to manage safely in very large classes. Also, let's be fair, it's simply not suitable for all topics. You can't exactly experimentally prove every single historical or purely theoretical concept. And finally, it requires highly trained teachers. It requires teachers, exactly like you, who understand how to guide an experience rather than just dictate facts.
Well, that brings us to the end of our explainer on this incredibly dynamic method. As you step into your future classrooms, the choice is really yours. Are you going to just lecture at them, or will you inspire your students to observe, experiment, discover, and innovate? The tools are officially in your hands now. Thank you so much for your focus today and for your dedication to becoming truly exceptional educators.